So we're going to go over an intersection of a line with a plane, and that's what these examples below are talking about. And then after in this lesson, we're going to go over the intersection of two lines. So I didn't technically need that title for this. We're just going to focus on this video. We're going to focus on a line in a plane. So in the first example, we have our line here. And our line is intersecting the plane, and it crosses it at a specific point. So if we're talking about solutions to this, how many solutions would there be for this line crossing this plane? Or how many points would there be? One. Woo! There'd be 1 point. So it crosses at this 1 point. There's only one solution to these two, if we're going to do it algebraically, two equations when they cross each other. So that would be our first case, we'll say. Okay, so this will be called our case 1. Case 2 is when our line is parallel to the plane. Okay, I guess this is the best way to represent that. This plane and this line are parallel. So how many solutions, or how many times will the line cross this plane? None. There'll be 0 solutions to case number 2. And finally, case 3 is when the line is on the plane. Okay, how many solutions will there be for a line that is on a plane? Infinite. That's right. We have an infinite number of solutions. Okay, so this is kind of like going back into grade 10 when you guys are going over to space, and we just have intersections of a line, right? You have your options of when they intersect each other once, when they're on the exact same plane, which has an infinite amount of solutions, and when they're parallel to each other, so they have no solutions. So first what we're going to talk about is example 1 in your book. So we'll jump to the next page. Example 1 says determine the point of intersection between the line. Okay? The line, represented by this equation, vector r having point 312 plus direction vector 1, -4, -8. Okay? And our parameter is all real numbers. And they're talking about the intersection point between this line and this plane. And the plane is represented by 4x plus 2y minus z minus 8 is equal to 0. Now, we have to find out if there's 1, none, or infinite amount of solutions. Okay? So, what we're going to do first is we're going to put our first equation in parametric form. Okay? So, we're going to take our line, and we're going to put it into parametric form. So, we know our x value here is 3. So, x will be equal to 3 plus 1s, or just x, or sorry, s. Y will be equal to 1 minus 4s, and z will be equal to 2 minus 8s. The reason we've done this now is because I now have a value for x, which I'm going to plug in, a value for y, which we're going to plug into the plane, and a value for z, which we're going to plug into the plane. Okay? This will help us discover what our parameter is. And by parameter, I mean our s. And once we find that parameter s, we'll be able to plug it in to our equation again to find out the exact points, or the exact point it crosses at. So we're going to plug this into our Cartesian form of the plane, where we have 4, and instead of x, we're going to put 3 plus s, plus 2, 1 minus 4s, minus 2 minus 8s. Minus 8 is equal to 0. Okay. We'll do the algebra here quickly. 12 plus 4s plus 2 minus 8s minus 2 plus 8s minus 8 equals 0. Alright, we'll try to collect our like terms. We have positive 4s minus 8s is negative 4 plus 8 is positive 4s. So I have positive 4s. And we have 12 plus 2 is 14 minus 2 is 12 minus 8 is 4. All equal to 0. Okay, so we have 4s plus 4 is equal to 0. We move the 4 over. We're going to end up with s equal to -1. Okay, so we've now found our parameter. So we're going to take that parameter, we're going to plug it into the parametric form of our equation, which is essentially what we had back up here. And these are going to give us the coordinates of where the line crosses through the plane. This will give us our x coordinate, our y coordinate, and our z coordinate to it. So we're going to take those. Our x value is equal to 3 plus, and since s is -1, 3 minus 1. Y will be 1 minus 4 times -1. And z will be equal to 2 minus 8 times -1. In this case, we get x equals 2. Y is equal to 1 plus 4 is 5. And z is equal to 10. So we've just discovered that this line crosses the plane at the point of 2, 5, and 10. Okay? So this is our point, and if we want to check just to make sure we've got the right answer, we can take these values. We'll highlight them again so you can see how they correspond. We can take these values and plug them in to our Cartesian form of the plane to see if it holds true. Okay? So 2, 5, and 10 will plug into 2, 5, and 10, or x, y, and z. And if this side ends up equaling 0, then we know we've carried this out properly. So we're going to check it just to make sure. Cartesian form of the plane was 4, and instead of x, we're going to plug in the number 2 plus 2 times 5 minus 10 minus 8 is equal to 0. This gives us 8 plus 10 minus 10 minus 8. And we get 0 is equal to 0. So we know that this, because this holds true, this is a point on the plane, and this is actually specifically the point where our line crosses through the plane. So that is our case 1, which we have there.